Hello, my dear students. Good morning to each one of you. Hope so you all are fine and studying these digital classes seriously. So, dear students, yesterday, as in the yesterday's video, we have finished our 4 colligative properties. So today, I'm going to start with the topic osmosis, osmotic pressure, types, and reverse osmosis, abnormal molar mass, Bentov factor. These are very small topics, and sometimes the questions are coming from these topics. So I am making a special video related to this topic. So welcome to digital classes. समय 10 से 12 वाला हर घर बने पाठशाला. This is unit 2. We are doing solution chapter. So let's start the osmosis. As yesterday we already did. So once again, let's discuss the definition of osmosis first. It is the phenomenon of flow of solvent molecules through a semi-permeable membrane. It can be written as SPM. In short form, semi-permeable membrane, SPM. So, through semi-permeable membrane, molecules from pure solvent to the solution side is known as osmosis. It can be also say in this way also. Listen carefully. The osmosis, it is the flow of solvent molecules from lower concentration, which is dilute solution, to higher concentration of solution, that is the concentrated solution. It is due to osmosis. When these two liquids are separated by semi-permeable membrane, that time it is called osmosis. Second, from semi-permeable membrane, what is the meaning of semi-permeable membrane? Its flow only stop when some extra pressure is applied on the solution. That extra pressure is known as osmotic pressure. So before going to osmotic pressure, what is semi-permeable membrane? Once again, it allows the solvent molecule only, but doesn't allow solute molecule to pass through it. So as you know that in a solution there is solute and solvent. If the membrane which allow the solvent only, not solute, that kind of pressure is called, that kind of process is called osmosis, and in which the some extra pressure is applied, that extra pressure is called osmotic pressures. So the extra pressure that must be applied to the solution side to stop the flow of solvent is called osmotic pressure. So already we discussed this numerically yesterday. Experimentally it has been found that for dilute solution, osmotic pressure, which is pi, is proportional to the molarity. Molarity is written here in the form of C. So we know already according to gas theory, pi V is equal to nRT, where pi is osmotic pressure, V is volume, R is gas constant, C is molar concentration of solution, which is called molarity also, and T is temperature. Okay, so if we will see the value, pi V is equal to nRT, so pi become n upon VRT, and n upon V we know about it can be written as a C in form of molarity. So it become pi is equal to CRT, the formula, okay, where n is the mole of solute. So when you will put this equation, when you know about this equation, then we can find out the some of the numerical related to this formula. Okay, so now we are going to classify on the basis of concentration of the solution and hence applied osmotic pressure. There are 3 basic type of solutions, which is called hypertonic, hypotonic, isotonic. These are 3 types. Hypertonic is exo-osmosis. Hypotonic can also known as endo-osmosis, and isotonic is a normal isotonic solution. Okay, normal saline solution. So hypertonic solution, let's discuss. A solution which have more osmotic pressure than the other solution, which is known as hypertonic. Okay, and if we'll take as example, so let's discuss with the example of an egg. When you will put one egg in a saline water or a water, so you can see the water is going to be shrink. Egg is going to be shrink. If egg will shrink, it means that the concentration of egg is more inside, so it will flow out. That's why it is called exo. Exo means external, out. So that type of process is called hypertonic solution. In this case, osmotic pressure of water is less than the egg. Then the concentration flow from inside the egg to outside the egg. That's why the result egg will shrink. Whereas in hypotonic, it is opposite to hypertonic. Endo-osmosis process, a solution having less osmotic pressure than the other solution, which is called hypotonic. Hypo mean thick. Sometimes students are getting confused. So hyper, thin, hypo, thick. Thick mean it will going to be swell up. It means that from the outside the concentration will go inside the egg. So in this case, the osmotic pressure of egg is less than the concentration of water, which flow from water to egg, and its result the egg will swell up. Whereas in isotonic, iso word is same, so two solution having same osmotic pressure at a given temperature, so there is no transfer of any concentration. It means that the whatever size was the egg have actual, that is the size will be later on also. In this case, the osmotic pressure of egg and water is same, and there is no transformation of concentration. As a result, the no change is there in size, so that's why it is called isotonic. So there can be question can be asked, differentiate between hypertonic and isotonic. So in that way, hyper, hypo and iso we can define. So osmosis in day-to-day life, as we can see, some question can come, what is the osmosis in our daily life, what is the role of osmosis in daily life. So first is in human being, it can be edema, dead bodies underwater. It is as you know, when dead bodies remain underwater for few time, PR, it will going to be swallow. Circulation in our body, germination in seed, preservation of meat, dry fruits, veg bean in water. Already these things we discussed in previous video also. So here one interesting topic is their reverse osmosis. Now although you know the meaning of reverse is it will go to the previous position. Osmosis, you know the concentration of solution from lower to higher with the help of simple membrane. So we will take the example of this reverse osmosis in case of our desalination of seawater by reverse osmosis. Okay, so it is the direction of osmosis can be reversed if a pressure larger than the osmotic pressure is applied to the solution side, and now the pure solvent flow out of the solution through semi-permeable membrane. It is called reverse osmosis. This method is used in desalination to get salt-free water from seawater. Here, this side the pressure is more than the osmotic pressure. You can see pressure is greater than the osmotic pressure. As you can see, the pressure we are increasing from this side, salty water side, and other side the pressure is going to be least. Okay, so through semi-permeable membrane, the pressure is exerted from opposite side, which is greater than the osmotic pressure. That process is called reverse osmosis. So these are the two topics: osmosis, osmotic pressure, and reverse osmosis. Next we will discuss about the abnormal molecular mass, okay, which is also very important. But before that, let me tell you how we can determine the experimentally the osmotic pressure. Experimentally we can determine the osmotic pressure with the help of Pfeffer's method, Barke-Hartler method, de Vries plasmolytic method, Morse-Fraser method, and Townsend's reverse osmotic method. Okay, although this is not in your syllabus, but main things you need to keep on. Rest discussion we will do if there is required. Welcome to the second part of this video. This is related to abnormal molecular mass and Bentov factor. So as we need to discuss the definition of abnormal molecular mass. So what is the meaning of abnormal molecular mass? As the name is just abnormal, it means that it is not normal. So this topic came from colligative properties. As we know that colligative property depends upon the number, not on the nature of solute. So as more as the number, so it can be changed. As more and molecular mass, it will change somewhere the colligative properties. So let's discuss about the abnormal molecular mass. Dear students, the molecular mass determined by colligative properties measurement is either less than normal due to dissociation or more than normal, that is due to association. So when we are talking about the concept of dissociation and association, somewhere we will see we are talking about abnormal in molecular mass. This is called abnormal molecular mass. Okay, so quantitatively, if the extent to which a solute is associated or dissociated, it can be expressed by one factor, that is called Bentov factor. This is very important topic also. Many times this question has been asked in your exam, that state Bentov factor. So let's discuss Bentov factor. Obviously this is the scientist name, and what is the factor? It is denoted with I. So this factor is used to predict the nature of particular solute in one solution. To predict the nature of particular solute in one solution is called Bentov factor. As we can define it, it can be defined as the ratio of normal molar mass to experimental determined molar mass. Ratio of normal molar mass, what is the exact molar mass, or what experimentally we determine the molar mass, that ratio in between, that whatever is the ratio, that can be known as I. So it means that Bentov factor can also expressed in terms of molecular mass. So first, I is observed colligative property upon normal colligative property, or you can say calculated molecular mass upon observed molecular mass. Okay, so let's discuss the value of I, how it can be predict the nature of solute in solution, what is Bentov factor, and why the Bentov factor is there, and how we can express the Ventov factor that we are showing. So there are three conditions. If I Ventov factor is equal to 1, if it is unity, then it means that solute behave normally in solution, and the observed property of colligative is equal to the normal colligative property. Whereas when I is greater than 1, value of I is more than 1, if calculation by mathematically we will calculate and value is coming more than 1, it means that solute undergoes dissociation, and in which case observed colligative property has more value than the normal colligative property, as this value is in I is minus 1 is equal to alpha whole bracket n minus 1. So alpha is I minus 1 upon n minus 1. By putting this formula we can calculate the degree of dissociation. Similar with third is I is less than 1, so it is opposite to this, solute undergoes association in solution. It means that its magnitude of observed colligative property is less than the normal colligative property, as alpha is equal to I minus 1 upon here 1 upon n minus 1. This is the difference only. Here n minus 1 simple, here 1 minus n minus 1. So although these are theoretical concept, but some of the numerical is coming related to Ventov factor, so I'm going to share it in the form of PDF. So dear students, as usual, you need to practice that PDF numericals, and if any problem you are facing, you can call me, you can ask me. Okay, so this is all about the unit 2. Tomorrow I will make the video related to summary of unit 2. It is will give you the whole recapitulation, whole mind map of the chapter 2. Although all the topics we have studied very effectively, and I tried my best to make you understand. Now you will give me feedback how was the topics. So dear students, so with this the chapter unit 2 is finished. So hope so you understood everything. But till my next video, take care, stay home, stay safe, and keep enjoying these digital classes. Okay, so thanks for watching the video. Thank you. Have a nice day.